Hello, my name is Abiodun Margaret Oyedele, and this is my mid-semester project. This project is a console-based patient management system that demonstrates the use of data structures, queue, and double-linked list. Queue for the patient waiting room and double-linked list for the patient history navigation. So I have different layered structure for this project. The For the history, this basically helps with taking care of the patient history list. I have the double node, which has different instance variable. The patient record, which represents like the data for the node, then a next node for the double linked list, and the previous node for the double linked list. I also have a default constructor and a parameterized constructor. Then for the patient history list, I have four instance variables. I have the head of the double linked list, the tail of the double linked list, and that's in the patient history record, the size, and also for current. I also have default constructor and a method to return the size of the patient record in the history list. Then a method to create a new double linked list, which is used in the add to patient record method, which receives a patient record and a location. Then I have validations. For instance, if the patient record is null, it sends a user-friendly message to the console. Then I have another method to print the patient record from head to toe. I also have another one to print the patient record from toe like tail to end. Rather, tail represents the newest record in the history list, while head represents the oldest record in the history list. Then I also have another method to display the newest patient record, another one to display the oldest patient record, another method to navigate to the next patient in the history list, then another method to navigate to the previous record, because this is a double linked list where you can navigate to both the next and the previous, unlike the single linked list where you can only navigate to the next and you can navigate easily rather to the previous record. Then a method to get the current patient record. Then this two method is basically to check if the current position is the newest record and if the current position is the oldest record. Then this is where I seeded 10 different datas into the system. Immediately the application is run, you have this 10 different records, 10 different patient records. Now, patient, which is used in the waiting list, the waiting queue, I have um I have four different instance variables. The ID, the ID counter helps to generate a unique ID for each patient. So on the console, the user don't need to put in their ID, and this actually helps with validations so that different IDs, the same ID, are not imputed differently. It just takes away a lot of headache. Then a name and reason for visits variables based on the um based on the requirement of the project. I have a default constructor for the patient and a parameterized constructor for the patient. Then I have getters and setter method for each of the instance variables. Though I don't have a setter method for ID because I don't need it, since the ID counter helps to set the ID. And then I have a toString method to this helps to format out a readable patient object. Then I also have a model for the patient record. These are the instance variable used: visit date, diagnosis, then the treatment note for each patient, a default constructor, a parameterized constructor, then getters and setter methods for each of those instance variables, and a toString method, which helps to, this actually also helps to override the toString method for the patient record, and as well give a readable format for every when this method is being called. Then this is where the logic of the waiting patient queue is being done. This is where you can, this method handles adding patients to the queue. Then this helps to check if the waiting patient is empty. This serves the next patient. Serving the next patient based on the requirements is actually removing the patient that is being, we actually remove the patient that is being served. And we can also insert patient at position, at any position, as far as it is within the size of the list. And this is done based on emergency case. And the position is zero based index. So you start counting from zero down to the last size. Then I have a print all patients in the queue. This helps to print all the patients in the queue. And this basically returns the size of the patient in the queue. Then the main method, this is where and this is the entry point of the interaction in the console. Then I also have tests, two different tests methods. I tested the patient history list and as well the patient waiting queue. So now I'll be going to the live demonstration of the application. So I'll start with the waiting room, and that is option one. Once this is run, you get this welcome to patient management system, and I'll start with option one. And option one, you have different things at which you can do. You can add patient, save next patient, emergency add patient at any position within the size of the list, then as well print the queue, then go back. So I'll start with adding a patient. Let's say we want to add a patient, Kennedy. Then the reason for the visit, let's say flu. And now the patient is added and you get a user-friendly message on the console. I'll be adding another patient for the reason of this demonstration. The name Brian, probably the reason for visit is cough. And now we have two patients added. I'll be printing this out and this will print out, that's with option four. This prints out the patient in the waiting queue. And let's assume there's an emergency patient that needs to be added, and that will be done with option four. Probably we have Taye, then the reason for the visit, headache. The reason for the visit is headache. And now for inserting to position, it gives a user readable. It does not just give you, it does not just say you should insert a patient at any position. It gives you the range at which you can insert the patient at a position. And since this is a zero based insertion, and we have just two patients in the queue, so we have from 0 to 1. If you pick a value that is beyond this one, you get you get an error message that says invalid position. Insert patient within 0 to 1. Let's say I will be inserting the patient at 1, and now the patient has been inserted. If I print out the queue, I have the patient inserted at 1, that's 0 1. Then the one patient moves to position 2, and this is done with the node. Then to save next patient, like I initially said, next patient when saved will be removed from the queue, and this will start from the oldest patient in the queue. This follows the real hospital way of saving patients. so that serving patients will not feel unreal and unrealistic. So you serve from the first patient that comes in, that is FIFO, first in, first out. I use the FIFO logic in this. If I serve the next patient, I get the first patient in the queue. That's Kennedy, and Kennedy has been served. If I print out the the list, I have just two patients left because Kennedy has been saved and he has gone. My next patient is Taye. If I serve the next patient, I can see Taye is being printed out. If I serve another patient, I can see the last patient, Brian. If I serve a next patient, I get an error message that says no patient in the queue to serve. And now I'll be going back to demonstrate the patient history. For the patient history, like I initially said, I seeded 10 data into the system. I'll be showing all records. I can show records both in, this is in reverse order. I can also, that is from newest to oldest. That is from the tail to the end. The tail is the newest data being entered. The head is the oldest data. If I show all records, this gives me from oldest to newest. And now if I show newest record, we can see we have follow up because this is the newest detail. And that is what we have below here, detail. If I show the oldest record, the flow, and that is what we have here, the flow. And if I show next record, the next record after the flow is spring. And the oldest record, okay, the next record after the flow is spring. And if I show the previous record is flow. And this is actually done because this is a double linked list. You can take the current the node to the next, and you can also point it back to the previous, unlike the single linked list that you can just take it to the next. And now if I show the current record, definitely it has to be the flow. And I can I can go back, and this will take me back to my console. To properly explain the patient history list and the patient waiting record, basically the patient waiting record follows the FIFO principle, that is a queue, first in, first out. And that is the patients were added in the order at which they got to the hospital. The first patient that got to the hospital is the first patient that was served. And after that patient is served, it is removed from the hospital. And the queue is appropriate here because it typically serves patients in the order at which they arrive. If I had used a stack, it would have actually been unfair, like I explained earlier. It would have actually been unfair and unrealistic because that means the oldest person, that is the first person that arrived, will never be attended to. Only the new people that gets to the hospital that will be attended to. And definitely in an hospital ward, it would have been very, very unrealistic. For the patient history list, a double linked list is actually used. A double linked list is actually used, which allows both forward and backward navigation. So when I try to, this is the all the records from oldest to newest. And when I get the next record, it gives me this. When I try to go past this next record, it says this is the newest record. That is, there's no other newest record. So it returns the newest record based on the requirements of the project. And the double linked list helps to move forward and backward. A double linked list is appropriate here because it allows the navigation in both directions. A double linked list is appropriate because it allows navigation in both directions using the next and previous pointers. And if we forgot to update the next pointer and the previous pointer correctly, it could make the list corrupt and the nodes could be lost. or the navigation could break. I also wrote a couple of tests, like I initially said. For my patient history test, I wrote a test to test all the history lists. For instance, to make sure that the current record is actually the current record in the list. I also tested the previous record using the get visit date. I tested the newest record, the next record, the previous record. I also tested if empty list is being added, make sure that the expected behavior is actually what is gotten. For the patient waiting list, I tested add patients, I tested serve next patients, I tested insert patient at position, and I make sure that all those tests actually ran correctly without no errors. This is for the patient waiting list. The three tests actually ran. Then for the patient history list, as well, the two tests also ran. The possible improvements to this system: one, connecting the system to a database for persistent storage, definitely. And if there's persistent storage, I might not need to be seeding data, for instance. I might just be adding data. Then also implementing like a priority queue for advanced emergency handling. For instance, there are in an hospital ward, there are some emergency cases that cannot be let go. For instance, if a new emergency case comes in, there should be a sort of priority. The emergency cases that are already on ground, are they more serious than the one coming? Like that will give a room for where the new emergency case can be put into the system. And also adding a graphical user interface. Definitely this will make our lives easier. And adding like a search and edit functionality for patient record, so you don't have to be using the pointers. You can just search in addition to the double linked list that is being used. So in general, in total, this project demonstrates the practical use of queue and a double linked list alongside testing and safe navigation logic. Thank you.